Welcome to This Explainer. Today we're diving into a genuinely fascinating GitHub repository by a developer named Manish Koti. It's called the Sale_AI, and it completely bridges the gap between raw numerical data and actual human understanding. You know, if you've ever stared at a massive spreadsheet or a complex dashboard and just felt entirely lost, well, you are in the right place. We're going to see exactly how modern application architecture is stepping up to solve that exact problem. Let's jump right in.
I want you to picture this. You're looking at a sales chart. Suddenly, right at the very end of the line, there's this massive, totally unexpected jump, a huge spike in sales. Now you know instantly that something happened, right? The chart proves it. But looking at that jagged line, you have absolutely no idea why it happened. Was it a new promotion? Did a social media post go viral? Did a competitor's website crash? The data alone just sits there, completely silent.
And honestly, that right there hits the nail on the head for a universal business pain point. Traditional math and data science, they're fantastic at playing detective. They can dig through millions of rows of data and spot those hidden anomalies perfectly. But finding the anomaly just isn't the same as understanding it. We don't just need a detective, we need a translator. And that is exactly the problem TCL AI solves. It synergizes strict statistical time series analysis with the contextual interpretation of a large language model. Basically, it finds the what, and then it uses AI to explain the why.
But before we even get to the AI part, we need that mathematical detective to do its job, to parse the uploaded sales data and automatically spot those hidden spikes or dips. The Sale AI uses a Python library called Pandas to calculate what's known as a rolling 30-day z-score. And the real beauty of this concept is just how brilliantly simple it is. It constantly looks at a moving one-month window of your data, establishes what normal actually looks like for that specific time frame, and then instantly flags any data point that strays a little too far from that localized norm.
So you might be wondering what actually qualifies as too far. Well, in this specific repository, the magic number is 2.5. This is the exact z-score threshold the application uses. If a data point z-score crosses that 2.5 line, the system definitively flags it as a statistical anomaly. It's literally the mathematical trigger that wakes the rest of the application up.
Putting these two approaches side by side really reveals the true power of this tool. Over on the left, you've got your traditional time series analysis. It gives you the hard numbers and it plots a timeline, which is beautifully visualized here using an interactive plotly chart, by the way. But that's where the traditional tools just stop. Now look at the right. This is the second half of the project, LLM contextual interpretation. The second the 2.5 threshold gets crossed, the application dynamically builds a prompt and fires it off to an LLM to generate a clear, human-readable explanation. It pairs the visual chart with an AI-generated narrative to give you the whole story.
All right, moving into Section 2, the decoupled architecture, back-end versus front-end.
If we lift the hood on how this thing is actually built, we find a super strict decoupled architecture. It's designed to completely maximize scalability and separation of concerns. Over on the back end, which is powered by Fast API, you have the heavy-lifting computational engine. This guy handles all the Pandas data processing, runs the outlier detection, generates the JSON for those plotly charts, and manages the LLM API integration. Meanwhile, the front end, built with Streamlit, stays entirely lightweight. It does literally zero data processing. It just takes your CSV upload, shoots it over via HTTP post to the backend, and then neatly renders the chart and text it gets back. It is a wonderfully clean setup.
So, how exactly do these pieces talk to each other? The Fast API backend exposes two specific endpoints to make the magic happen. First up is the /health endpoint. This one is purely for container orchestration readiness. It just lets the system know, hey, the backend is fully awake and ready for traffic. Then you have the /analyze endpoint. And this one is the real workhorse. This is where all that Pandas processing, the anomaly detection, and the LLM API integration actually take place.
And if we take a look at the actual language breakdown of the repository, it perfectly reflects that architecture we just talked about. The project is incredibly focused. It's 97.6% Python, covering both the Fast API backend and the Streamlit frontend. The remaining 2.4%, that's just the Docker file code, a tiny but absolutely crucial containerization layer that wraps the whole shebang up.
Let's look at Section 3, Resilient AI Integration and Graceful Fallbacks.
Now this brings us to what is easily one of the most robust developer experience features in the entire repository. Look, when you're building with AI, things happen. API keys fail, networks go down, or maybe you're just coding on an airplane without Wi-Fi. This Sale AI handles this brilliantly with a graceful fallback sequence.
First, the system tries to connect to Anthropic's Claude API. But if you didn't provide a key or the connection fails, it doesn't crash. Instead, it seamlessly defaults to a local Llama instance running right on your machine, like the Llama 3 model. This means offline development and local testing are absolutely never blocked. Such a smart architectural move.
And finally, Section 4, launching the application.
Okay, so you're probably thinking, how can I actually get this running on my own machine? Thanks to Docker, the setup process is wonderfully snappy. Step 1, just copy the provided .env.example file into a new .env file to get your environment configured. Step 2, run docker compose up -build -d. This command automatically orchestrates both the backend and front-end containers concurrently. Step 3, verify everything is happy by curling that /health endpoint we discussed over on port 8000. And finally, just navigate your web browser to localhost port 8501 to pull up the Streamlit UI.
And the best part? Once you're in the interface, the repository already includes seed data, so you can test it out instantly. You just grab the sales_history.csv file from the data folder, drop it into the Streamlit UI, hit that Analyze button, and then just watch. You get to see the backend crunch the math, plot the interactive chart, and query the LLM to deliver a perfectly translated, human-readable insight into your data.
Oh, and real quick, for all the developers tuning in, I do want to point out this project's serious commitment to code quality. The core statistical logic, the actual math calculating that rolling z-score and finding anomalies independent of the web framework, is fully covered by unit tests. You can run the automated test suite locally whenever you want just by running pytest test/. It's a great way to ensure the math stays completely reliable as the project scales up.
So, we've seen how Thesale AI takes a totally unexplained sales spike and transforms it into a clear, AI-driven narrative using a perfectly decoupled architecture. But before we wrap up, I want to leave you with this question to chew on. What other data needs a translator? Seriously, think about your own projects for a second. If you could synergize raw statistical math with the conversational power of large language models, what other hidden stories in your data pipelines could you completely bring to life? Thank you so much for joining me for this explainer, and keep building.